Dear students, today we will go for organic chemistry, new chapter alcohols, phenols, and ethers. Here you can see alcohols, phenols, and ethers are the basic compounds for the formation of detergents, antiseptics, and fragrances, respectively. Let us go for the study in detail. First of all, we have to study what are alcohols and phenols and ethers. Alcohols and phenols are formed when a hydrogen atom in a hydrocarbon, such as aliphatic or aromatic, is replaced by OH group. You know the formula of alkanes, CnH2n plus 2. When you remove one of the hydrogen atoms from alkanes or alkenes or alkynes in simple hydrocarbon by OH, which results in either alcohol or phenol. For example, you can say this is methane. Carbon atom is attached with the four hydrogen atoms. Therefore, this is hydrocarbon and this is methane. Now, one of the hydrogen atom is replaced by OH. Now, it results in what? Alcohol, which results in alcohol. This is methanol. Methanol. Another benzene. You know the formula of benzene. C6H6, all the six carbon atoms are attached with one hydrogen atom. Now, one of the hydrogen atoms is replaced by OH that gives us phenol. That gives us phenol. That's why alcohols and phenols are formed when a hydrogen atom, not only one or more hydrogen atoms of hydrocarbon such as aliphatic or aromatic by OH. These classes of compounds find wide applications in industry as well as in our day-to-day life. For example, you might have seen that means the wooden furniture polished, which are polished are compounds made up by what? Hydroxyl containing compound or hydroxyl group compound. Example ethanol. Example ethanol. And sugar we will eat. The cotton used for fabrics, paper we use for writing are all made up of compounds containing OH group. So that's why these are the simple two examples given here, especially the uses of alcohols. But other than that, also plenty of uses we know in our daily life. Let us study the details. Another class of compounds are there. Already we studied water alcohols, we have studied phenols. Then we come to know what is an ether. If from hydrocarbons, if you replace one of the hydrogen atoms by either alkoxy, that means alkyl group containing oxygen, or aryl group containing oxygen. That's why either alkoxy or aryloxy, which results in ether. Which results in ether. For example, you can say dimethyl ether. Here methane, actually this is what? Methane, CH4. One of the hydrogen atom you remove, you will get what? CH3. Substitute that by what? Alkoxy, CH3O. Now it results in what? Ether. That's what? ROR. General formula you can write for ethers is ROR. Example, here it is methane. Already said it is a methane. Now you remove one hydrogen, substitute by alkoxy or aryloxy, where R is either alkyl group or aryl group. Similarly, for benzene ring, hydrogen atom, we have all the six carbon atoms attached with the hydrogen atoms. One of the hydrogen atom is replaced by alkoxy or aryloxy, which results in what? Ethers. Which results in ethers. Examples you can see 2H5OCH3, CH3OC3H1, etc. You can write this is alkoxy because all these are alkyl groups, and this is aryloxy because there is aryl group present in the ring, where R is alkyl or aryl group. Next, we can move on to the classification of alcohols. How alcohols are classified? They are mainly classified into mono, di, tri, or polyhydric compounds. How? That clearly based on the number of OH groups present in the compound. If the compound, if it contains only one OH group, if the compound contains only one OH group, then it is called monohydric. If they contain two OH groups, then they are called dihydric. Similarly, three OH group trihydric, and if they contain more than three OH groups, then they are called as polyhydric compounds. They are called as polyhydric compounds. Students, remember the classification here: mono, di, tri, etc. based on the number of OH groups present on the present in the compound. Present in the compound. If the compound contains only one OH group, then it is called monohydric. If they contain two, then it is dihydric, and three for tri, and so on. You can say example ethyl alcohol. Here it contains only one OH group, therefore it is monohydrate. This is also monohydrate because it contains only one OH. Another example, ethylene glycol. Here you can see there are two OH groups. The compound contains two OH group. Another here also the compound contains two OH group. Therefore, these two compounds are example for dihydrate. An example for dihydrate. Another example, glycerol. You can see there are three OH groups are attached here, or the compound contains three OH groups. Similarly, here also the compound contains three OH groups. That's why the compound which contains three OH groups, they are called as trihydrate. They are called as trihydrate. This is what the classification based on the number of OH group in the compound. Number of OH group in the compound. Next, once we know the compounds are monoditrile, the monohydric alcohols, they are further classified into the different categories based on to which carbon atom the hydroxyl group is attached. Whether the hydroxyl group is attached to sp3 hybrid carbon atom, sp2, sp, and so on. That means, especially this is the classification based on to which carbon atom or to which hybridized carbon atom the OH group is attached. The OH group is attached. We will go one by one. First, compounds containing sp3 hybrid carbon atom with OH. That means the OH group is attached to sp3 hybrid carbon atom. sp3 hybrid carbon atom. In this class of alcohols, the OH group is attached to sp3 hybridized. sp3 hybridized carbon atom of an alkyl group. That is clearly said. To which hybridized carbon atom the OH group is attached. Here in this classification, we are going to study the OH group is attached to sp3 hybrid carbon atom. sp3 hybrid carbon atom. This is further classified into primary, secondary, and tertiary alcohols. Then, what are the primary, secondary, and tertiary alcohols? Condition number one, OH group must be attached to sp3 hybrid carbon atom. Now the second condition, in primary alcohols, the OH group attached to sp3 hybrid carbon atom, and that carbon atom must be primary carbon atom. That carbon atom must be primary carbon atom. What is primary carbon atom? A carbon atom is attached with one other carbon atom or no other carbon atom. The carbon atom is attached with one other carbon atom or no other carbon atom is called primary carbon atom. To such carbon atom, if OH group is attached, then that type of alcohols are called primary alcohols. Here you can see this is primary alcohol. Why primary alcohol? Carbon atom is sp3 hybridized. Condition number one, carbon atom is sp3 hybridized. Second one, this carbon atom is attached with only one other carbon atom. Therefore, this is called primary carbon atom, and these type of alcohols are called primary alcohols. They are called primary alcohols. Then secondary. Similarly, you may come to know what is secondary. What is secondary? A OH group is attached to sp3 hybrid carbon atom, and that carbon atom must be secondary carbon atom. What is secondary carbon atom? A carbon atom is attached with two other carbon atoms. A carbon atom is attached with two other carbon atom. Then that carbon atom is called secondary carbon atom. Here the secondary carbon atom and it is sp3 hybridized. Therefore, this type of alcohols are called secondary alcohols. They are called secondary alcohols. Now the tertiary. Similarly, the OH group is attached to sp3 hybrid carbon atom as well. That carbon atom must be tertiary carbon atom. Condition same. Tertiary carbon atom. The carbon atom must be attached with the three other carbon atoms. The central carbon atom must be attached with the three other carbon atom. Then that carbon atom is called tertiary. If the OH group is attached to tertiary carbon atom, then that alcohol is called tertiary alcohol. That is called tertiary alcohol. So clearly remember, primary, secondary, tertiary alcohol, they are classified on the basis of to which carbon atom the OH group is attached. Condition number one, the carbon atom must be sp3 hybridized. Condition number two, whether the carbon atom is primary, secondary, tertiary. If the carbon atom is primary, then the resulting alcohol is called primary alcohol. If the carbon atom is secondary, then the resulting alcohol is called secondary alcohol. If the carbon atom is tertiary, then the resulting alcohol is called tertiary alcohol. Let us go for some example. Say here, this is ethyl alcohol primary, and this is secondary alcohol because the carbon atoms are attached with two other carbon atom. Therefore, it is called secondary, or it's also called isopropyl alcohol. And this is tertiary because the carbon atom to be OH attached. The carbon atom to which OH attached is attached with the three other carbon atom. Therefore, that alcohol is called tertiary alcohol, and the name is tertiary butyl alcohol. Tertiary butyl alcohol. Now, another sp3 alcohols or sp3 hybridized alcohol, allylic alcohol. What is allylic alcohol? Here the OH group is attached to the carbon atom. That carbon atom must be sp3. That carbon atom must be sp3, and that carbon atom must be attached with a carbon-carbon doubly bonded molecule. That means the OH group is attached. You can see OH group must be attached to a carbon atom. That carbon atom must be what? Must be sp3 hybridized. This carbon atom is sp3 hybridized, and to this carbon atom, other carbon atom is attached that must contain double bond. That must contain double bond. This type of alcohols are called what? Allylic alcohol. Students, remember here the OH group must be attached to that carbon atom. Which carbon atom? Which should be sp3 hybridized, and that carbon atom attached to another carbon atom containing double bond. Another carbon atom containing double bond. Such alcohols are called as what? Allylic alcohol. Here it is allylic primary alcohol, and this is once again like secondary alcohol because sp3 carbon atom is attached with two other carbon atom, and one carbon atom contains double bond, therefore this is secondary. And once again we can find tertiary because sp3 carbon atom attached with the three other carbon atom, out of three one carbon atom must contain double bond, therefore this is the tertiary allylic alcohol. Remember, allylic alcohols are further classified into primary, secondary, tertiary based on to which carbon atom the OH group is attached. The OH group must be attached with the sp3, and that sp3 must be attached with the doubly bonded carbon atom. Doubly bonded carbon atom. Next, the category of the same is benzylic alcohol. Here, what is benzyl? A aromatic ring, nothing but benzene ring, is attached with the side chain having CH2 group. Having CH2 group is called benzyl group. If OH group is attached to benzylic, attached to what? Benzyl. Benzyl, here the benzyl side chain containing carbon atom must be sp3 hybridized. Must be sp3 hybridized. Such alcohols are called as what? Benzylic alcohols. Then just observe, we are also classified into primary and secondary tertiary. Here you can see this is primary. Why it's primary? OH is attached to benzyl group. This is called benzyl group. A benzene ring attached with the side chain having CH2 group. Benzene ring, a side chain with CH2. This whole group is considered as benzyl group. To benzyl group, if OH is attached, then it is called benzylic alcohol. And this is benzylic primary alcohol because the carbon atom attached with only one other carbon atom. Therefore, it is primary. And secondary. Here, this also benzyl because side chain attached with the carbon, and that carbon atom is attached with the two other carbon atom. One is here, another one is here. Therefore, this is called secondary benzylic secondary alcohol, and this is tertiary because OH is attached to benzyl group, and that carbon atom is attached with the three other carbon atom. Therefore, this is tertiary benzylic tertiary. Once again, they are classified into primary, secondary, and tertiary based on to which carbon atom the OH group is attached. So this is the classification of the alcohols. That means the OH group is attached to sp3 hybridized carbon atom. Remember, based on hybridization, sp3 hybrid carbon atom to which OH group is attached, they are classified into primary, secondary, tertiary, and then allylic and benzylic. Allylic and benzylic. Both allylic and benzylic, they are further classified into primary, secondary, and tertiary. Primary, secondary, and tertiary. The second, sp2 hybridized. So far we are discussing about sp3 hybridized. Now sp2 hybridized. In sp2 hybridized, the carbon atom must contain at least one double bond. At least one double bond. Here the OH group is attached to the sp2 hybrid carbon atom. Here OH group is attached to sp2 carbon atom. How to identify the sp2 carbon atom? That carbon atom must contain one double bond. That carbon atom must contain one carbon-carbon double bond. Then that carbon is called sp2. To that carbon atom, if OH group is attached, then that is called as sp2 hybridized COH bond. They are further classified into vinylic. These alcohols also known as what? Vinylic alcohols. Example you can say OH group is attached to sp2 hybridized carbon atom. This is the carbon atom and it is sp2. Why it is sp2? Because simply we can remember this carbon atom is having double bond. Therefore we can say it is what? sp2, and OH is attached to sp2, and this is called vinylic alcohol. This is called what? Vinylic alcohol. Another example you can see here phenols. You can see OH group is attached to carbon atom having double bond. Here also OH group is attached to carbon atom having double bond. Such alcohols are called as what? Vinylic alcohols or sp2 hybridized carbon atom containing OH bond or OH group. Next, once we come in to know that, now how to name the compound. That's what the major and very important part of the chapter. How to name. Nomenclature. Once we know the compound, it's our target to name. In common name, we can name them as alkyl alcohols. Alkyl alcohols. Say for example, methyl alcohol, ethyl alcohol, like that. Alkyl group as such, the common name of derived from the common name of alkyl group by adding alcohol to it. That's what in one word we can say alkyl alcohol. Alkyl alcohol. Methyl alcohol. Say CH3. You know how to call CH3. CH3 is nothing but what? Methyl. And OH is what? Alcohol. Therefore, we can call it as methyl alcohol. Similarly, we can call C2H5OH. How can we name that? C2H5 is ethyl and OH is alcohol. Therefore, ethyl alcohol. And so on. While naming in IUPAC system, while naming, we have to follow certain rules. What are the rules? Rule number 1. Every alkanes, the name ends with E. We know, no doubt, we have very clear methane end with E, ethane end with E, propane end with E. That E is replaced by OL. Replaced by OL. OL means ol. Ending E of the alkanes, is replaced by ol. Simple rule number 1. Remember, every alkane whose end name always ends with E, that E is replaced by ol. Say example, methane ending is E. Now you replace that E by what? Ol. You will get what? Methanol. So the name changes to methanol, or in common alkanol. Alkane and E replaced by ol. Therefore you will get what? Alkanol. You will get alkanol. Now suppose if the chain is length which contains substituent, you know the substituent, alkyl groups are substituent, nitro, halogens, that may be different substituents we have. When we have the substituent, they have to given the position by the numbers. We have to give the number, lowest possible number. Then how to start the number? While starting from that end, means rule, we have to go for what? Longest chain. Either direction you can start, left, right, or any direction. When whatever may be the direction you can go through, the longest chain you have to choose, and the lowest possible number must be given to the that carbon atom containing OH group. Remember, go for the longest chain. After choosing the longest chain, give the lowest possible number to that carbon atom containing OH. That carbon atom containing OH must be given the lowest possible number. If OH is present at the one of the ends, suppose OH group is present at one of the ends, and that carbon atom started as first carbon atom, and then we can continue the longest chain. For naming polyhydric alcohols, E of alkane is retained and the ending ol is added. Remember this, polyhydric. That means if suppose there are 2 OH groups are present or 3 OH groups are present, in such a case, we should not remove E of the alkane. Suppose ethylene glycol we have, ethylene glycol. While naming, we should not remove ethane, we should not remove that E, it remains as such. Then you have to give the position of OH group, and then you have to name the compound. Number of OH group is indicated by adding the multiplicative prefixes di, tri, etc. before ol. Alright. The positions of OH groups are indicated by appropriate lock-ins. For example, you can see here there is ethane and two OH groups are attached to it. Here we should not remove E of the ethane. It has to be retained as such. That's why this is two carbon atom, then this is ethane. And first position and second position, both the positions are attached with the two OH groups. Therefore, if I start from here or from here, one and the same. Therefore, 1, 2. First position contains OH, therefore 1. Second position contains OH, therefore this also 2. Therefore 1, 2, and there are two OH groups, therefore di and ol is added. This is what the method of the nomenclature of polyhydric alcohols. That means the alcohol which contains two or more OH group. Remember, while naming polyhydric alcohols, do not remove E of the alkane and you retain as such, and note down the position of the OH group, to which carbon atom the OH groups are attached. Note down its position and then add the number of the OH groups by using prefixes like di, tri, etc. and add ol and add ol. This is what the rules we have to remember while naming the compounds. Students, do remember while naming the compounds by IUPAC system. Very simple. If it is monohydrate, then ending E of the alkane replaced by ol. If the uh, compound is the long chain compound, suppose if it contains substituents, then the substituents are given the position by numbering 1, 2, 3, etc. But while naming or while numbering, you just remember the lowest possible number must be given to that carbon atom containing OH group. Then you can start the numbering from any of the directions. If suppose alcohol containing more than two OH groups, then you do not remove E of the alkanes, it retains as such, and then give the numbering to the chain, and then write the position of the OH groups and add the prefixes based on the number of OH group present in the compound and add O at the end. Some examples you can go for, say compound and its common name and IUPAC name. First, this is CH3OH. I think you know its name. Common alkyl alcohol. Therefore, it is methyl alcohol. Methyl alcohol. And while naming IUPAC system, only one carbon atom is there. Therefore, it is and one OH group is there. Therefore, it is monohydrate. Simple rule. It is methane. Replace E by ol. Therefore, you will get what? Methanol. You will get methanol. Another example. There are three carbon atoms. Therefore, it is propyl and alcohol. And it is straight chain. Therefore, it is called N-propyl alcohol. Normal. And how to name IUPAC? Longest chain contains three carbon atoms, therefore it is propane. And ending E is replaced by what? Ol, therefore it is called propane. And position, you can see first position containing OH group, therefore it is propane, 1 ol. Suppose if the OH is present at this carbon atom, then also it is called propane 1 ol. In such case, you have to start numbering from this direction. That's what I said in the rules. Lowest possible number to be given that carbon atom which contains what? OH group. You have to start from that end. Here, since OH group is attached here, therefore this is the first carbon atom. If suppose here it is attached, then this is the first carbon atom. Now you can see the carbon atom is present at the middle. So we should not start numbering from here. We have to start either from here or from here. That means numbering always start from one of the ends. Here you can start from either here or here, one and the same. Therefore, you will get what? Second position OH is present. Therefore, we can common IUPAC system we can follow 1, 2, 3. Therefore, it is propane 2 volt. Why 2 volt? Because second position containing OH. In common, this is isopropyl. therefore it is isopropyl alcohol. And in IUPAC, I've said rule numbering from in one of the directions. Therefore, this is the direction 1, 2, 3, and second position contain OH group. Therefore, it is called propane 2-ol. Propane 2-ol. Now, the longest chain contains 4 carbon atoms and it is a straight chain. Therefore, it is called what? N. And 4 carbon atoms, therefore butyl and alcohol. Therefore, it is called what? N-butyl alcohol. While naming IUPAC, follow the rules. Longest chain containing 4 carbon atoms. Where from you start the naming, numbering 1, 2, 3, 4. Do not start from this direction because OH group is present here. You have to give the lowest possible number to that carbon atom containing OH. Therefore, it is the first carbon atom here and 4 are present. Therefore, it is butane 1-O. Butane 1-O. Now you can see once again here in common it is very simple. It is a secondary butyl alcohol because OH group is attached to secondary carbon atom. Secondary carbon atom. And the thing is, while naming by IUPAC system, you can go. There are two ways you can number. One way you can numbering from this direction. You will get 1, 2, 3, 4. Second position contain OH. If I start from here, 1, 2, 3, 4. Third position contain OH. Which is the lowest number? 2. Therefore, we have to start from numbering this direction. 1, 2, 3, 4. 4 carbon atom, therefore it is butane. And second position contain OH, therefore it is called butane 2-ol. Butane 2-ol. You can see this is tertiary butyl alcohol. Why means OH group is attached to tertiary carbon atom, therefore it is called tertiary butyl alcohol. While naming IUPAC, how to name? We cannot start from here because this is not, it is a middle carbon atom. We can start from here 1, 2, 3. If you start from here 1, 2, 3, or you can start from here 1, 2, 3. However, you can start, you are getting 3 carbon atom. But second carbon atom contains OH as well. Second carbon atom contains what? Methyl group. Therefore, longest chain I can go for this. If I consider this is the longest chain, second carbon atom contains OH and second carbon atom contains CH3. Therefore, this is named as first substituent to methyl. And the 3 carbon atom is the longest chain, therefore it is propane. And second position contains OH, therefore it is 2-ol. Hence, the name of the compound is given 2-methyl propane 2-ol. Now, how to name the cyclic compounds, cyclic alcohols? While naming cyclic alcohols or cyclic compounds, they are named using the prefix cyclo. This is important. You remember, cyclo. Cyclo name is given first. And OH as usual. The carbon atom to which OH is attached, that is considered as first carbon atom because this is the functional group. If other functional group is there more prior than this, then that carbon atom is given number 1. But here in this case, only one OH group is present and that carbon atom is considered as first carbon atom. If suppose there are substituents, in this case, you can see OH group is present, CH3 is present, therefore OH group, this is considered as first carbon atom and this is the substituent and lowest possible number next we have to give, therefore 1, 2. We should not move via this because this is gives the highest number 2, 3, 4 and 5. We should not go for that and we have to go for the lowest possible, therefore 1 and 2. This is 1 and this is 2. And here it is named. And this is there are 6 carbon atom, therefore the hexane and OH is there, therefore ol is attached. Cyclo is since it is cyclic compound, cyclo is attached, cyclohexane ol and cyclohexanol. Here second position contains methyl group, therefore it is called 2-methyl cyclopentanol. Why means second position contains methyl group and first position is OH and this is the functional group and the 5 carbon atom, therefore it is pentane and OH is there, therefore it is ol and second position contains methyl, therefore it is 2-methyl cyclopentanol. 2-methyl cyclopentanol. So this is the classification and nomenclature of the alcohols. Student, try to remember nomenclature is the very important part of the uh, organic compound. Once you know how to name the compound, it's very easy to write the question and answers. And how to name, I repeat once again, how to name the compounds while naming it in IUPAC system. If you have to check whether the compound is monohydric or polyhydric. If monohydric, the ending E of alkane is replaced by old by giving the position of the OH group. By giving the position of the OH group. If suppose the compound is polyhydric, contains two or more than two OH groups, then you should not remove E of the alkene. You have to retain as such and give the positions of the carbon atoms containing OH group and add the prefixes of the OH group, whether they contain 2, 3, etc. and add ol. If the compound is cyclic compound, then cyclo, the word cyclo is added as prefix. And the carbon atom to which OH group is present, that carbon atom is considered as first carbon atom. And then the substituents given the lowest possible number from any direction. Any direction.